right because these are very large cells, very round. Sometimes you'll see them like that, kind of squished in between three other cells, but that nucleus belongs to one of those three, which is very different from lung tissue where it's simple squamous epithelium because these lines would be a bunch of nuclei, right? These are the cytoplasmic, this is the membrane cells. Okay, but adipose, we'll see that in multiple places, but that's probably the easiest, second easiest tissue. The easiest is probably bone. My lowest magnification? What do you think this is? So we're in connective tissue, so you only have so many options, right? Remember, you kind of want to make the practical easier for you, which still requires work, but you kind of get to, okay, I know this is an epithelium, so I see way too much space between where the cells could be for this to be an epithelium. So it's probably a connective tissue, or maybe it's muscle. Muscle doesn't look anything like this. So then I think, well, I only have, well, you have quite a few connective tissue options. So there's like 10 of them, or something. But what do you think this is? It is on page 12. Good idea. Definitely a good idea. I'll prove that this isn't. Yeah, it's actually, it's easier to explain what it is than to defend why it's not everywhere. So I see lacunae. Each of these white spaces are empty, and there used to be, there's a cell that's still left behind, but in each of these spaces would be a cell. Those spaces are lacuna. Does anyone remember where lacuna, what tissues have lacuna? So cartilage and bone have lacuna. These lacunae are nice and round and open, which tells me it's probably cartilage. Also bone looks the way that bone looks. So this doesn't look like bone. We'll see that in a second. Now, what are my three options for cartilage?
Elastic, fibro, hyaline.
Elastic, fibro, and hyaline. Hyalose means glass. So hyaline cartilage is going to look like smooth glass. What I think it looks like are grains of sand, because you'll still see this kind of general pattern. It looks like grains of sand embedded in smooth glass. Is this glass smooth? No. This looks like shattered glass, maybe like really tiny spiderweb shatters. Because what you're looking at with all this dark purple, and especially like down here, I can zoom in a little bit more. Actually, I can zoom in quite a bit more. So that was pretty zoomed out. This still isn't even my highest magnification. But I can see these individual protein fibers, right? Hyaline cartilage, you're not going to see protein fibers. It's going to be an amorphous ground substance, which means it's all going to be generally one color. I can pick out individual proteins. That makes this elastic cartilage. Those are elastic fibers in between. Okay, fibro cartilage also has protein fibers. It's not completely different from this though. So I think elastic cartilage looks like grains of sand embedded in shattered glass. So we'll see hyaline. Questions on elastic cartilage though? Those are lacuna where the cells are. So in some of the samples, like this one, I mean I do see some cells, right? But like that's empty, that's empty, that's empty. Sometimes it'll just look like empty holes. That's where the cells used to be, but they got pulled out during the process. Now this slide is called elastic cartilage. Like we talked about last time, maybe what that means is you get zoomed in and you're looking out here and you want to say, hey, here's elastic cartilage. That's not elastic cartilage, right? So you still need to go find what you're looking for to look more like that. Right, there's some type of epithelium. There's some salivary glands, right? So maybe you zoom in and you say, well, that looks like something that's interesting, and it is, but it's not elastic cartilage, because that's what elastic cartilage is. Okay, what type of tissue do you think this is? So these are lacuna. You kind of see like the little white halo around this cell. That's an empty space called lacuna. So this is either cartilage or bone. that's because of staining. That's because the way the histo ended up for this slide wasn't great. But within that, it's smooth. I can't see individual protein fibers. So this is hyalose, this is glassy cartilage. So this is one that I think looks like grains of sand embedded in smooth glass. Okay, even out here, that's muscle. But even out here is a really good view because it's just smooth in between. But you can see all these lacunae with the little nuclei inside of them. Alright, so outside of the cartilage, there's not too much to write home about for these cartilages. You just need to be able to tell the difference. What type of tissue do you think this is? Interesting. What type of this? Okay, so our obstacle right now is to be able to tell the difference between dense regular connective tissue, smooth muscle, and fibrocartilage, because all three of those look pretty similar to each other. This is not muscle, but I do agree it kind of looks like smooth muscle. So we're gonna have to figure out, okay, how am I gonna tell the difference between those? This is dense regular connective tissue. This is bottom of page 12, right 6 point, oh wait, no, sorry, this is number 6 at the bottom of page 12. It's called white fibrous connective tissue there. The real name is dense regular connective tissue, okay? Now this slide is called white fibers, so you might be able to find it. It's in tendons, it's in ligaments. So I'm pretty zoomed in. What do we notice about this? We have quite a few cells, right? But there's also a ton of space in between them. That's gonna be the difference between this and smooth muscle, one of the differences. Smooth muscle, what makes up that tissue, all those proteins are inside the cells. And so to get the same area, the same amount of volume, you need a lot more cells, which means you're gonna see a lot more nuclei in smooth muscle than this. Also, notice how flattened these nuclei are, right? They're crushed. Because there's so much protein in between these two cells that it doesn't leave any room for the cells to actually exist, and so they stay flat. Remember in cartilage, there's a lacuna, there's a little house for those cells to exist in. So in fibrocartilage, it might look very similar to this, but I'm gonna see a lacuna. I'm gonna see a little bit rounder of cells because they're not as crushed because they live inside their little house. Dense regular connective tissue has relatively few cells, and they're all gonna be extremely squished like this. Let me try to find smooth muscle first over here. See how similar that looks over here? But what do we notice? There's a lot more cells there than what we were just looking at. Okay, and I know these nuclei are still pretty flattened, but they're not little slivers anymore. They're a little bit chunkier, especially if you find here's a good view. There's just way too many cells for this to be a connective tissue. Connective tissue overall does not have that many cells per square inch. Here's a ton of nuclei, which means there's a ton of cells here. And these nuclei are, I agree they're still like pancakes, but they're a little bit more oval instead of thin little strips like we just saw with the dense regular. Should I go back to the dense regular so we can compare? Not nearly as many cells, and the cells that are here are crushed. Right? Those aren't too bad, but these guys are all flattened completely. Just look up here in this corner. Not a cell to be seen because there's so few. If this was smooth muscle, I'd at least see 5 or 6 just within that little area. What do you think this is? That's simple squamous epithelium. That's a capillary in longitudinal section, which is kind of crazy. you see? What do you notice? How would you describe what you're looking at? Is there relatively a lot of cells or not that many? Quite a few, I would say, right? I mean, look up here how densely populated this part is. It gets a little sparse out here, but even then, it's quite a few. These nuclei, I can even see like the nucleolus of these nuclei, which means they're not crushed completely flat. They're squished. They're fusiform is the term for smooth muscle. But they're not flattened like if this was dense regular connective tissue. So now we need a medical, right? Tons of cells. So this is smooth muscle. This is also smooth muscle. What type of tissue? Why? Okay, why? Somewhat, maybe. A little bit. It's definitely irregular. It definitely has an organization to it. But so does dense regular connective tissue that we just looked at. Why is this not dense regular connective tissue? I don't see that many cells. I see proteins going in one direction, which is what we saw with the pink slide. So maybe this is just a blue, dense regular connective tissue. Do we see anything else that kind of stands out to us? Like Lily said, there's not that many cells, but what do we notice about the cells that are there? They're not squished like flat, like dense regular CT is, okay? There's not that many cells, so it's not smooth muscle. But the cells that are there are relatively round because they're actually inside a little lacuna, which is specific to cartilage. So this looks just like dense regular, except the color. But everything else about it, truthfully, everything else about it is dense regular connective tissue. It's the same organization, it's the same protein fibers, and instead of being built by a connective tissue proper, it's built by cartilage. So those cells build their own little lacuna semi-solid matrix around them. So this is this is fibrocartilage. So we've done all three cartilages, and we've done one of the two connective tissue propers, or one of the three, I guess, in the form of dense regular. We've done one of the three. Repeats or questions while I kind of got it. What type of tissue is this? Yeah, adipose. This is kind of a rough view for you guys. So I'll try to find some other examples. But what tissue do you think this is? Does it look stronger to you? I mean, yeah, okay. Down here you guys see the vertical stripes? So there's some striations. But even then it's pretty rough to tell, and at the back of the room you may not even see those, okay? But I can still confidently say this is skeletal muscle. Because if I back, that was my highest magnification. If I back this off to pretty low, what do we notice? These cells are huge, right? This is one cell going the whole distance across the screen. There's like 1, 2, 3, 4, 5, 6, 7, there's like 8 maybe right here. Going left to right, those are massive cells, very, very long. That's skeletal muscle. Okay. Now, ideally ideally, I would have been able to find, the reason why this is a problem is because I don't see a lot of nuclei, and I also don't see the striations super well, so let's see if I can find it. But I think I'd still need to be fair for the tests. What type of tissue? Oh, okay, so these white spaces are fake. So I don't really see white spaces around too many of these cells. What do you guys think? Can you see how the pink around it kind of goes with it? So this is smooth muscle. This is all smooth muscle. This is a little bit like it's coming out of the screen like this. So it's not perfectly flat, it's kind of coming out like that. You're kind of getting a rounder nucleus because of the way it's slicing. But what type of tissue do you think this is? Close. The question is, why is this cardiac, even though these cells are very long? I don't really see striations, so that didn't help too much, although cardiac muscle is also striated anyways. And so this is kind of tough, because cardiac muscle should be branched. But you're not really going to see typically where one cell ends and the next one starts. You'll find intercalated discs. I'll try to do that for the actual test. I'll try to find some more in a second. Ideally, I would have those in the view during the test so that you would have that context. But I'm going to show you why you don't need that context because I don't see any intercalated discs here. And the reason why I still am confident that this is cardiac muscle is because these nuclei are in the middle of that cell, right? And you can even see, if you're close enough to me, you can see there's like it's almost yellow, but there's a little faint area here, a fainter area there. Over here you can see it's yellow for some reason on either side. That's because all the proteins that make up those sarcomeres, that make up the striations that you normally see, they're being forced around the nucleus, because the nucleus is in the middle of that cell. Skeletal muscle, those nuclei are going to be squished to the side of the cells. And we're going to see a lot more, a lot more of them. They're going to be flattened against the side of the cell. So they would be almost like this little nucleus or this one here, but just on the sides. Whereas this is cardiac muscle because I see massive cells in the middle and I see clearings around them. That's a really good sign that this is cardiac muscle. If I'm wrong, that would be crazy. This slide's supposed to have all three muscle types on it. See the difference? These nuclei, that nucleus is in this cell, but it's squished to the side of it. Same thing with all of these. That's in between, these are two different cells, so that space is not inside a cell. So that cell is squished to the side of maybe this one. this is one cell, a different cell. All those nuclei look like they're in between cells because they're all squished to the sides of it. I still don't see any striations. So. Some of these are little capillaries, but here you still see those nuclei squished to the sides. So this has to be skeletal muscle. This part of the muscle, this is probably tongue. You have a lot of muscles going in random directions, skeletal muscles going in random directions in the tongue. So we have some muscle here that's going in the same plane as the TV. And then this is skeletal muscle coming in and out of the TV. And so you're cutting each cell off, so it looks like a little circle instead of a long stripe. So you might see that. I think I have better dedicated striated muscles somewhere. You know, at least you can see the striations. This is skeletal muscle as well. And you might think, well, those nuclei don't look like they're necessarily pushed one way or the other. And I agree, it's kind of tricky to use that rule where we said cardiac muscle nucleus is in the middle of the cell. Well, here I can't really see where one cell ends and the next one starts, so it's a little bit trickier. But look at the sheer number of nuclei. And this is one of the tables on page 15. It asks for multinucleated or uninucleated. Skeletal muscle is heavily multinucleated. You're expecting to see dozens of nuclei per cell. So I look at this and I see a lot of nuclei and I see striations, therefore it's not smooth muscle, but it's the same number of nuclei, so there's a lot of what could be cells there, but instead it's a lot of nuclei fused into one. For cardiac muscle, I'll just tell you, you can put, actually what I want you to put is multinucleated for cardiac muscle. But that's like a possibility. It's possible for cardiac muscle to be multinucleated. The standard that you're expecting to see though is roughly one nucleus per cell though. Because when they are multinucleated, they only have maybe two. They're not going to be hundreds like we see here, where all of these nuclei are part of one cell. It's probably going like this. Okay. So that's all three muscle types. Okay.
not a connective tissue because that's a lot of cells. It's a lot of nuclei. It's not adipose. It's not epithelium because there's so much space between the nuclei. And we are not doing nervous system, so that only leaves one more tissue type, which is muscle. So which are the three muscles? Smooth muscle, then, well, okay, first let me ask this. Is there direction to what we're seeing? Like, can you pick out, oh, this tissue is going left to right, or it's going up and down, or it's going in and out of the screen? Okay. Any ideas?
Do you see these protein fibers wisping left and right?
Can you kind of see that?
Okay, so if this were smooth muscle, then it would be cutting it as it's traveling like this, and we would see those nuclei nice and oval. They'd be stretched because we can tell that it's going left to right. And these nuclei are not stretched like that. That one is. They all look like that one. Instead, these guys are a little bit rounder. And then I look at this and I see, well, there's like a clearing on either side of this. If it were skeletal muscle, that wouldn't be there. You'd have the cells squished back. They'd all look like that one. But most of these nuclei, I have, let's see, like this one, clearing on either side of it. Okay, and then what are these? Those vertical lines.
Those are intercalated discs. If you can find a cardiac slide, I haven't been lucky so far, but there's several up there. If you can find a cardiac slide that has clear intercalated discs, that would be really great for drawing because
That's what I'll try to find for the practical, is one that has crisp ones. There's an intercalated disc. Now you can actually see some striations. This is the best example we've seen so far, what I mean by those clearings. Okay, this is one cell. Cardiac muscle cells are pretty big. Here's a nucleus. On either side of it, I see a clearing because those protein fibers, you can see them literally swimming around the nucleus because that nucleus is in the middle of that cell. Skeletal muscle would be pushed out to the side. Here's some decent intercalated discs as well.
we need to do bone. We need to do a couple other. What's this? We agree, bone? Very good. You don't need to tell me compact bone, you don't need to tell me spongy bone, you don't need to tell me osteons, lacunae, canaliculi, osteocytes, any of the details that you might remember from other classes. This is what bone looks like. It looks like Swiss cheese. What you're really seeing are these osteons, right? Not just the holes, because you might have like adipose, kind of looks like giant. It's more, okay, I have these donuts that are sandwiched together. That's bone. Okay, but I don't think I need to expand too much more on that. That's, I think, the easiest one here. Okay.
What type of tissue is this? This is my lowest rank tissue. There's a little bit more zoomed in. From here to the top of the screen is all the same tissue. Not simple. Stratified, right? Yeah. Okay, especially if you zoom in on stratum granulosum. these cells are a little more flat, a little more disc shaped. Anyway, so that's stratified squamous from last time. So what do we expect to be right underneath any epithelium? Basement membrane, I can't see the basement membrane. What tissue do I see underneath epithelium? So the golden rule is anywhere I have epithelium, the next layer is probably going to be areolar connective tissue. Because this is somewhere towards the top of page 12 with me. So here's the line between the epithelium and the connective tissue. And here, this is all areolar connective tissue. Areolar means loose, and it's because it's mostly ground substance, which means all this blue fuzz are really small proteins, and then there's empty space where there would be water whenever it's actually in your skin. Notice how when I scroll down from this areolar connective tissue, all of a sudden I have massive protein fibers, right? These are bundles and bundles and bundles of collagen. That is dense, irregular connective tissue. Up here in the papillary layer, even right here, this softer, fuzzy stuff, that's areolar connective tissue. The proteins aren't nearly as big, and they're not nearly as organized. Okay? So areolar connective tissue, a good place to find it is just deep to the epidermis of the skin. And then deep to that, the reticular layer of the dermis is going to be dense irregular, which is 6.1 on the bottom of page 12. Okay, you need to add that in. 6.1 dense irregular on the bottom of page 12. The best place to find that is the reticular layer of the dermis, where we've spent some time before. So again, on the practical, in this one view, I wonder if I can get in this one view I have, which I want to do this to you, but if you can study this much to where you're most comfortable would be great. This is stratified squamous, this is areolar, these are capillaries, so there's simple squamous, and then there's dense irregular, and then there's stratified colloidal. That's what I want. Right, that's the kind of, you don't have to do it that quick, obviously. But that's where you want to be close to when you go to practical. And then I scroll down and I see what? Out of those, what do you think this is? It's a little bit tougher, but that's, I think that's still. Stratified, bunch of stratified colloidal there. Adipose next to stratified colloidal. Simple squamous epithelium. Sorry, we have to do blood. Blood. So on the practical, the question will be 9 times out of 10 ID tissue. So you're going to answer things not like epithelium, but you're going to say stratified colloidal epithelium. Not muscle, but you'll say smooth muscle or cardiac muscle. You'll say one specific type, right? That's going to be your answer for almost all the questions, except for blood. The question will either be ID tissue, and you say blood, or it'll be ID cell. Okay, and we're only going to do 2 of the cells. So this shouldn't hurt you, this should be a good thing. So what cells do you see here? What are those? Yeah, these are just red blood cells, okay? So I might point and say ID tissue, and you say,
Red blood cell. Blood.
just blood, right? Blood is the tissue, it includes all the white blood cells, the red blood cells, platelets, it also includes the plasma and dissolved things in it. That's all blood, right? The screen is all blood. Also in the screen is just red blood cells. ID cell. It's not red, it's white. So it's just a white blood cell. We're not going to get into the specifics, that's probably a lymphocyte. But there's a whole bunch of other white blood cells for this practical. It's either red blood cells, white blood cells, or tissue, it's just blood. Okay? So
that one shouldn't be too hard for you. Whenever you do a drawing, I would draw a nucleus and all the cells, that's white blood cells, and no nucleus, red blood cells.
Those white blood cells might look kinda weird though, depending on the slide that I grab. But as long as you see purple and not just pink, it's a white blood cell. The slide, like this guy is kind of weird, it's like eosinophil, or no, it's not, it's a neutrophil. Even this guy, it's not super clear, but maybe that's the only one I can find. And there's just enough dark purple to tell you there's a nucleus there, that's another neutrophil. Okay, questions on any of the stuff? That's the red, we're not gonna do, if you're stopping, oh yeah, let me show you. So on page 12, C1, the mesenchyme, you can mark that out. I didn't define connective tissue proper for you, but we've looked at it. That's the dense regular, dense irregular, and areolar. Those are all C2 proper, so you can go ahead and do number 2. And then I added 6.1 at the bottom of page 12. And then on page 13, at the top, you can mark out number 7. Particular tissue really doesn't exist. That's put together. Don't forget that table for the muscle, right? And whenever it asks for nucleation, it's not a yes or no question. They're all nucleated. Is it nucleated or is it multinucleated? Okay. So you do the rest of page 13, and then on page 14, you'll do number 3 at the top. And then you won't do anything else. So part 5, nervous tissue, we're not gonna do. We're ending after on page 14, number 3 is very last. That's our last. Okay, but next week we're gonna do a whole bunch of system stuff, so that'll be good. Okay, questions on what we're not gonna do?
Well, we're not doing
I think
any of the
sarcastic.
page 15.
None of page 15. 16 should be blank for you. Rest of page 14. Number 3 at the top. Okay, other than that, it's the same rules as last week. Give me drawings with 2 things labeled. You can just do one magnification, whatever level it's best to do. The other questions, you're probably defining